Hi everyone, I am Denisan, and in this video I am going to show you how you can use the stage interaction system in your project. Stage interaction system will allow you to create local and gameplay interactions for your project. Local interactions are being the interactions that will only affect your game world, and they won't affect the other players' game world. And the gameplay interactions are being the interactions that will affect other players' world, such as interacting with this chest, for example. You could create any type of animations or particle effects that will trigger on your local machine or other players' machine. This interaction system will allow you to create whatever you want. As you can see, I use a stage tree to control these interaction stages. I have this debug view that will allow you to visualize this interaction. As you can see here, these are my interactables, and whenever I end up not interacting anymore, other players will see that too. For example, if I interact with this and go back to my client, I can't interact with this because it says someone else is interacting, but I can also interact with this. I will show you how I created this, and hopefully it will give you an idea how you can create your own interactions. So let's get started. So what are these gameplay stages that we are talking about? I've opened up my Paint to showcase this system. Best place to showcase a gameplay system, I think. So stages are actually a gameplay tags that we add to our item. And whenever we add these stages or gameplay tags to an item, we update their interaction by updating their gameplay tag container about that player. So every container has a player associated with it, so we can see what has interacted with what, so we can display the appropriate indication to our players. And as I said, we have two interaction stages mainly. One for indication. These are local interactions such as overlap, so that we can display outline effects or on our items. Other one is being the gameplay stages. We add them in the same way, and the result will be by a map. Keys are player states, because player states are replicated across all clients, and their gameplay tag container. So whenever we interact with an item, we update their gameplay tag container for that player. For local stages, we add the local player as a key and hold their gameplay tag container. For gameplay tag stages, we update the player states for that container, so we can see what is going on. And of course, we can remove the gameplay stages or indication stages and update the results. Whenever we update this gameplay tag containers, we output a delegate, so we can work with that information. I know that was a lot of words, but let's see the system in action. I have opened up my debug view by typing stage interaction enable debug mode 1, and we can see what we have added to the items that we are interacting. As you can see, local player 6, and we add these tags in interaction.indicator.overlap and interaction.indicator.hover. these are local stage interactions. As you can see, our clients has no idea about them, but they can add their own interaction stages. And whenever we add a gameplay stage, the result is actually replicated, so that we can see our client has seen that player had added this stage interaction.gameplay interacting. So we can't actually interact with this with our custom conditions. As you can see, I am trying to interact with it. It doesn't happen. So let's see how we can achieve this. So in order to create an interaction system, first we need an interactable actor. I'm going to open up my chest here, and as you can see here, I have added this component on C++, but you can add this component on blueprints just by typing stage gameplay interactable and add it like so. After you have added this component, stage gameplay interactable, you will see that we have two variables here. One for gameplay stage edit condition and other for indication state edit condition. Gameplay stage edit conditions are the conditions that will execute whenever we want to add a gameplay stage, and indication state edit condition is whenever we want to add a local indication stage edit condition. As you can see, we can add multiple conditions. If we want a custom gameplay condition, just create a blueprint class by stage edit condition. As you can see here, we have stage gameplay edit condition base and stage indication edit condition base. We could create our custom class, and for example, we have this overridable function, and we get stage is adding or parent interactable is the component that we are trying to add, and we can output the results. As you can see here, we have this result data. This is just a U object. You can create any U objects and output them here, so that players may know that what has gone wrong. So in your stage gameplay edit condition base, you could create any type of condition you may want. For example, you can check by getting the world if you are playing a cinematic, for example, or you could even check if the control pawn is near a parent interactable. You could check anything you want. You could create your own custom variables here just by creating a new variable. And you will see them in your conditions. For example, I have created this new blueprint and I will see the variables here. And there are some default conditions here. For example, we could have a multiple condition. This multiple condition will check every condition and only pass if every condition has passed. And we have also only single interactor in the gameplay stage edit condition. This will allow only one player to interact with this object. If no one else is interacting, everyone can interact with it. But if someone else is interacting, any of the players can't interact with that object. This will allow that. So we have this multiple condition here in the indication stage edit condition, and you can customize this on your own with similar logic, and that's it for the conditions. I have opened up my chest interactable to showcase this gameplay interactable component functions. We have gameplay stage functions and indication functions. Indications being the local functions. In our interactable components, we have this add gameplay stages, remove gameplay interaction stage, remove all gameplay interaction stages for player, and we can get the gameplay stages for that player. The player is the player state actually, and because player state are always replicated across all clients, we can get our player states from a character easily. Let's see here, gets player character and gets player state, and we can input this variable to these functions. And yeah, as you can see also, these functions are always server only, because we want to keep consistent across all clients. Indication stages are almost same as the gameplay stages. We add or remove, and we can get the gameplay tag container about the state, and we can check our indication gameplay tags. We have this player controller reference instead of the player states, because we need to actually the local player, and we can easily get the local player from a player controller. I used a player controller reference as input here because it is more easy to get the player controller reference in blueprints. We can always get player controller, input this, and you may seen that we can expand this and see more options. If we check the force adds, we skip the conditions that we have defined on here, and we won't get any output result data. If we don't check that, we can get this and break the output result data and get the metadata and display the information so that our players can know about what has gone wrong about this interaction, so that this is a very good way of informing our players what has gone wrong in the interaction. So these are the main gameplay and indication functions that we are going to work with. There are more, you can see them in the documentation, but for most of the cases these are enough. By the way, if you don't know how you can create your own gameplay tags for this, you can go to your project settings and go to gameplay tags and manage gameplay tags. Probably you don't have this much gameplay tags in your game, but if you can go to interaction, you will see gameplay and indicator will be there. They are here because you enabled this plugin, and you can create or add your own gameplay tags here. I have this interacting, hover, and overlap, but you can create your own stages and make the system more complicated. That's your option here. After that, you have added your gameplay tags. You will see them here and you can use them. So let's say that you have set up a system that will add or remove gameplay tag stages whenever you press E or go near them, for example. I will show you mine, but let's say that you did that. How do you process this data so that your player can see what's going on with this interaction system? As I said, we have these two delegates here on player gameplay interaction state changed, and one for on player interaction indication changed. Their output resembles same, but this player is player state and this player is local player. And whenever we add or remove a gameplay stage or indication stage, these delegates are fired and we can process the information here. So if we are a single player game, we don't need to check if we are the local player. and we can just go with this. If we have added this and the tag that edit is, for example, overlap, in that case we want to set a overlay material for our mesh and select the correct overlay material so that we can create the effect like outline effect, that glowing whenever we overlap with this item. And we all need to also check if we are not overlapped anymore, and we need to also check this so that if we can know we remove this overlap material, and we need to set the overlay material none in this case. So as you can see, this is for one indication stage, by the way. If we need more indication stages, for example hover or anything else, we need to add more of this code, and this is not very modular and not very scalable. We need something else. I'm not even talking about adding a gameplay stage interaction that also handles overlay material, and that would be nightmare. So we need a different approach to handle our gameplay and indication stages if we need to go more deep. And I have found that using a state tree is a perfect solution for this. We could use a state tree that handles all the edge cases and use tasks to implement the overlay materials, or for example mouse changes, etc., anything we want. And for that we just need to add a state tree to our item, and in there we need to create a state tree and we need to populate them. Let's see what I have done here. So let's look at what I have done here. I have these two main states and that we go into, any gameplay interaction and no gameplay interaction. If we have detect any gameplay interaction, we go in this state and we check if we are the local player interacting. If so, we do some tests here. If not, someone else is interacting with this item. If so, we do some tests here too. And if we are overlapped, meaning if the local player is overlapped with this item and hovered, we do some tasks here too. These are custom tasks. Yeah, if no gameplay interaction is detected, meaning the only local interactions are visible here, we check if we have overlapped with this item. If so, if we have hovered, and we do some tests. If not, we just overlapped with this item and we do some tests here too. So as you can see, we have all the cases that we want. We can go much deeper with this system, but this what I have come up with. You can create your own tests. I highly encourage you to check out state trees. It is very easy to create states, tests, considerations, etc. So that you can handle all the cases you want. So how do we update this state tree so that whenever an interaction stage gets added or removed, we find the correct state to go to? We need to create a global task to do this. At least what I have done is create a global task. You can create a custom global task just by creating a new task on the state tree task blueprint base and go to the states. As you can see, this is very simple. I have created a custom variables in the category of context. So it's whenever I add this state to the any state, it gets the context from the actor automatically. So and we have this output states, so that whenever we want to get the current states, we can use them. And this is a local components, which is a interactable component that we have added to our item. Whenever a gameplay stage gets changed or interaction gets changed, we have this two events that we can bind to, and whenever this happens, these two events gets called. As you can see, they do the same thing, just update the corresponding variables and send a state3 event with tag state3 event interaction.stage updated, so that we can update our state3 with this event. Whenever we exit the state, I unbind the events from this, just to be safe. You don't have to. So how do we use these events? We go to our root, add a transition with events, and required events. We select the correct events. What I have done is I set the tag to stage.updated and transition to root whenever this stage gets updated, so that we can reevaluate this state tree and we can go to the correct states by checking their conditions. To create conditions that we can use, you need to create a custom condition here, state3 condition blueprint base. I have did several and I will show these. Let's look at any gameplay interaction condition. As you can see, and this is a very simple condition. We check the player states, and we check if it's not empty, meaning there's a gameplay interaction. So we go in the states. Local player interacting condition is a bit much more complex. This is the overridable function, receive test condition. We checked the if we have a player that is local. By this, we get the player states. We check if it is a player controller, and we check if it is a local player controller. If so, we return true here with this function, and we do this for every player states that are in the states of this gameplay interaction. If we have find any, we return true. If we didn't, we return false, so that we can check if we are the local player interacting. These are much more simple. I use the already defined condition here, meaning the tag query does container match tag query. And if we have find any overlap, we go in the state. If we didn't, we go to no interaction. And if we have hovered with this item, we can check it here, and we can go to this task. I won't go into much detail with this tasks because they are very game specific, but let's look at this one. From the owner actor, we get primitive components and set their custom depths and set their custom depth stencil value, so that our post-process can draw an outline around them. As I said, this is a much game specific, so I won't go into much more detail about them. And yeah, this is how you create your own states and stages with this plugin. Finally, I want to show how I done my interaction detection for my game. This is very game specific feature, so you have to solve this problem your own. I will show you how I did it. As you can see, I have this overlap sphere around my character, and whenever I overlap with an item, I add a interaction.indicator.overlap tag to that item as an indicator, and same is for a mouse. Whenever I hover over an item, I add this stage called interaction.indicator.hover. I traced it from my character's head to the mouse location, so I can't interact with a object that is behind a barrier, for example. I use a gameplay ability to do this, but you can achieve a similar result by just adding a sphere overlap component to your character and add interaction stages whenever you overlap with an item. So this is how I set up my gameplay ability to interact. When I activate this ability, I also enable these two gameplay ability tasks, and for example, this task, which is a custom gameplay ability task, I have created this my own, almost scans every frame and with radius, and whenever I overlap with an item, I add interaction.indicator.overlap, and whenever I overlap with this item, I also remove the interaction.indicator.overlap stage from that component. Almost same from here. I add hover and remove the hover stage from here, and whenever I press an input, I do the same tasks and just add interaction.gameplay interacting to the interacted actor, so that I can pick up items, I can open chests, I can open doors, etc. As you can see, this is very game specific, but hopefully this will give you an idea how you can create a similar detection for your game. So I think I have covered everything that you need to know. If you want to learn more, you can always go to the documentation about this plugin. This cover and name of this plugin will change, and learn more about this plugin. If you have any questions or any recommendations, you can share them in the comments section. So see you next time. Goodbye.